Welcome back, guys. Tonight we're going to be talking about how to solve, create, and interpret compound inequalities. This is an extension of what we did in the last video. In the last video we talked about how inequalities have infinitely many solutions. We just drew the arrow, we filled in the dot depending on whether or not our number that we found was part of the solution set, and then drew an arrow one way or the other, indicating that all those numbers greater than or less than satisfied the inequality. But today we're going to talk more specifically about some instances where that's not always true. So when is there more than one solution? So there's more than one solution when we have an inequality, basically where any number that is greater than or less than a specific value satisfies that inequality or satisfies that solution. So in the real world, this actually happens a lot. In example 1, you don't need to write this down in your notebook, but the work you will need to. It says, look at the sign on Route 56 or Route 46 in Oklahoma. We can graphically represent the possible legal speeds that we can drive. So we can actually do this. If we look at the speed limit sign here, the speed limit sign says that the speed limit is 70 miles an hour and the minimum is 40 miles an hour. So if you think about the fact that you're driving down the highway, and if you're driving 55 miles an hour, you're driving within the speed limit, the range that they said is an acceptable driving speed. But if you're driving like 35 miles an hour, if you have a little like moped or a little scooter that only go 35 miles an hour, you're actually driving below the acceptable minimum speed limit. Or if you are, like many people, you are driving 75, 80, 90 miles an hour down the highway, you're actually going way too fast, so you're driving above the speed limit. So what we want to know is, how can we graphically represent the possible legal speeds that we can drive? So we have a minimum and we have a maximum. We're going to start by, if we're showing this graphically, we're going to start by, go ahead and we're going to show this on a number line. So I'm going to draw a number line here, and do this with me in your notebook. And on the number line, I'm just going to divide this up into tens. So this is going to be, let's say this is 30. These are miles per hour. So this is going to be 40 miles per hour. Here's 50. Here's 60. Here's 70. And let's say here's 80. Okay? So I'm going to switch to my red pen here. So if I think about what this is saying is, if I'm driving anywhere between 40 and 70 miles an hour, I'm driving within an acceptable speed to be on the highway. So I'm going to start by shading in from 40 to 70. Now I'm not going to go above 70, I'm not going to go below 40, because if I go below 40 or if I go above 70, then I'm either driving too fast or too slow. Now the question is, do I include 40 and do I include 70 in the acceptable speed limits? So here's where I have to go back and I have to really think about what this is saying. Let's start at 70. So the speed limit is 70 miles an hour. So I'm thinking to myself, if I'm driving 70 miles an hour, will I get a ticket, or am I breaking the law, basically? Well, if the limit is 70, 70 is going to be included in the acceptable speed limit. So the way that I represent that, and you might be thinking ahead to yourself, what is he going to say next? The way that I represent that is a closed dot at 70. Since 70 is part of the solution, I'm going to close the dot to represent that. Now, we go down here to 40. If the minimum acceptable speed is 40 miles an hour, is 40 included in the solution set? If it is, we're going to do a closed dot because that's part of the solution. But if it's not, then I'm going to put an open dot. Now, in the context of the situation, it's showing that the minimum is 40 miles an hour. So I think to myself, would I get a ticket if I was driving 40 miles an hour? And no, the minimum is 40. But if I was driving 39 miles an hour, would I be running the risk of getting a ticket? I sure would. So since 40 is part of the solution set, I'm going to go ahead and close that, put a closed dot at 40. Now notice what we've done here. We have two ends to our inequality, meaning there is a lowest, a minimum point, and a highest or maximum point. When we have this, what we've done now is we have a compound inequality. And the way that I would write that is that our acceptable speed, let's say we're going to use x. Let's say x represents our acceptable speed. So if we have x is greater than or equal to 40 miles an hour, and this is important, and x is less than or equal to 70 miles an hour, then we have an inequality here. We have a compound inequality, meaning we have two parts to our inequality. We have our acceptable speed with the minimum, it's greater than or equal to 40, and it has to be less than or equal to 70. Now, if I want to, I can go ahead and write this like this, where I've got x is less than or equal to 70, and x is greater than or equal to, I know I said that the wrong way, but when I'm thinking about this, I'm reading it now backwards. So where 40 is less than or equal to x, and x is less than or equal to 70. Two ways that you could write an and compound inequality. You're going to get to the now you try tomorrow. But for now, let's take a look at example 2. So here, I have to really think about what this inequality is saying. It's saying I've got two inequalities. K is greater than or equal to -2. Here's my first inequality. Or K is less than -6. So the value for K could be greater than or equal to -2. And so I'm going to go ahead and I'm going to graph that. Let's say I'm going to graph that one with a red pen. So here I've got, here we go, any number that is greater than or equal to -2. Here's -2. I'm going to go ahead and put in a closed circle because -2 is included in the solution set with that equal to section right here. So any number that is greater than or equal to -2. So -1 is greater than -2. 0 is greater than -2. All of these numbers that go to the right of -2 could be a possible solution set for K. Or, I'm going to switch to a blue pen here, K could be any number that is less than -6. Well, here's -6. I'm going to put an open circle at -6 since it's not part of the solution set. There's no equals to sign here with the less than. So K could also be, or it could be less than -6, meaning -7 is less than -6, -8 is less than -6. All of these numbers are less than -6. So the only numbers really that don't work for K are between -6 and almost up to, but not including, -2. So this area here that I have not shaded is the only part that is not included in the solution set. So what this is saying is K can be any number that is greater than -2, or it could be any number that is less than -6. And you can see that we've represented that in our graph of the number line. Now, for example 3, we have something that looks just a little bit different. And go ahead and write this in your notebook. Again, pause the video if you need to. But here I've got -4 is less than or equal to -2q, which is less than 4. I don't really like the way that this is written, because this, if we go back to example 1, is the way that we wrote our and inequality. That's how we wrote this right here. So what I'm going to do is I'm going to take what I have and I'm going to split it into an and inequality for example 3. So what I'm going to do is I'm going to scroll back down here. I'm just going to break this into two parts. I'm going to say, let's start with a red pen. I'm going to say, I know that -4 is less than or equal to -2q. And, here's the and part. Here's and -2q is less than 4. Notice I just took that center term or that center expression, what's in between the two inequalities, and I just split it up. I duplicate it. You can see that's written over here with a -2q. You can see it's written over here with a -2q. And I basically just rewritten this center part twice. And so I'm going to solve this as two separate inequalities. I'm going to say we need to, in order to isolate q, I'm going to divide both sides by -2. And since in this example I've divided by a negative number across the inequality sign, as that inequality sign drops down, it's going to pass through that negative field, or whatever you want to call it, and it's going to flip around. So it's going to be written as a greater than now sign, since I've divided by a negative number. And this then simplifies to be just 2, and I have q. And now I'm going to go over here to the blue side. Again, I'm going to have to divide by negative 2 to get q by itself, or isolate q. And because I've divided across the inequality with that negative 2 with a negative number, as this inequality gets brought down, it's going to change into a greater than sign. And here I have q is negative 2. Alright, so I'm going to go ahead and graph these. So this is where q is greater than negative 2, and 2 is greater than or equal to q. So I still have this and idea. Alright, so if I have 2 is greater than or equal to q, I don't like the way that's written. So I'm going to go ahead and I'm going to do what I can, knowing about inequalities where I've got the open sign to the 2. I'm going to keep that open sign to the 2, and I'm going to rewrite like this. Notice I've flipped the numeric in the variable terms, so I've also then flipped the inequality. It's just an easier way for me to rewrite this, so I can kind of see that any value that is less than or equal to 2 and any value that is greater than negative 2 is going to be my solution. So I've got any value that is less than or equal to less than or equal to 2. So here's this. This is less than or equal to 2, so I'm going to start to shade this way. And it has to be greater than negative 2. And it has to be greater than negative 2. Here's negative 2. Opened up because it's just greater than. I'm going to shade this way. So where these two lines overlap is this section right here. So what I have here is the shaded region with a closed dot at 2, an open dot at negative 2, and a line in between. Because this is the region where q is less than or equal to 2 and greater than negative 2. This is a compound inequality. Now you can see there's some differences between and inequality, compound inequalities, and or compound inequalities. These are sometimes true, but more so we want to rely on what we know about inequalities and what we can get from graphing and solving them, as opposed to trying to come up with like a one-liner rule for these. We want to understand the concept more than just the like one rules. So you guys are going to have a chance to work with these tomorrow. Make sure these are in your notebooks, and we'll see how you do tomorrow when you come to class. I'll see you in the morning.